One of our panelists is Paolo Antonelli, is curating a big exhibition planned in the Triennale in Milan, which is called Broken Nature. And there's also an exhibition that's planned at the next Cooper Hewitt Triennale in New York, which I'm involved in, which is also on the theme of nature. So what's new about this whole idea of bringing together nature with biology? It seems like, nature with fashion and design. It seems like design has always been working with biology. So in this panel, we'll really be looking at what's going on now, what's so different about the 21st century in the ways that designers and artists are engaging with nature. So I would like to, first of all, introduce my panel, tell you who we have. We have, first of all, Paolo Antonelli, who's the senior curator at the Department of Architecture and Design at the Museum of Modern Art in New York, and who has curated many exhibitions and projects that are intersectional, bringing together design and all sorts of areas of science. We also have Jens Klein, who is the founder, CEO of AM Silk, which is a company located much closer to Munich, in Planegg, just south of Munich, and who is working on creating incredible applications for synthetic spider silk. We also have Susanne Lee. So Susanne Lee is the Chief Creative Officer with a company called Modern Meadow, based in New York, who are doing incredible things in creating leather from collagen. We also have Maurizio Montalti of Officina Corpusculi in Amsterdam, who is working on, among other things, creating new materials from fungi. And last but not least, we have Fiorenzo Omenetto. It's amazing how many Italians we have today, actually. There's a whole thing about Italians and biodesign. So Fiorenzo Omenetto is the founder and professor at Tufts University and founder of the Silk Lab. So working on new applications of silk, among many other things, which you will hear about shortly. So I would like you now to warmly welcome our panelists to the stage. Thank you. Yeah. Wonderful. So grab a seat. Great. So first of all, I would like to hear from you, Paola, and I think you are somebody who has been an absolute pioneer in bridging design and biology, and it would be wonderful to hear from you from the design perspective, why you thought that this was an important area to get into in terms of design, and if you can tell us a little bit about your vision for this connection between design and biology.
Absolutely. I'm going to start with the first slide, if you don't mind bringing it on. This is not the first. Let's go back. Sorry, guys, we're not starting well. Okay, here, great. So design doesn't start with the design of the object. It starts with the materials. Materials are also designed. And I'm going to quote two exhibitions that I did when during my career at MoMA, not to be celebratory, but just because they were about materials as a form of design. This is the very first show that I did at MoMA. It was in 1995, and it was called Mutant Materials in Contemporary Design. At that time, I was not talking necessarily about biomaterials or organic materials. There were also some absolutely inorganic ones, but what had changed was the balance of design of materials. All of a sudden, with new resins, new composites, and new ways to actually build, the design of materials was in the hands of designers themselves, not only of engineers or scientists. So that was a big change that made clear where objects actually begin. And more recently, it's the 10th anniversary this year of an exhibition called Design and the Elastic Mind, where instead we introduced at the Museum of Modern Art the idea of biomaterials. Actually, we didn't tell anybody, but there was a living entity in the exhibition. You see it on the right-hand side. So the exhibition was about designers and scientists working together without the membrane of technology separating them. And one of the objects in the exhibition was victimless leather, which was a little coat very, very small coat made of mice stem cells. And it was in an incubator. I didn't tell MoMA that there was going to be an incubator and a living entity in the exhibition, because it's always better, as you know, to ask for forgiveness than to ask for permission. So we had this little thing that was growing, as usually happens. You start with a scaffold, you put some proteins on, then you put you feed it and it grows. And it was growing too fast. And so all of a sudden it was like one sleeve was dangling, it was breaking down, etc. So the wonderful designers that are Symbiotica, Oron Katz and Zora in Australia emailed me and said, you have to stop it. And I said, what do you mean I have to stop it? And said, you have to turn off the incubator. And I said, I had to kill the coat? And they said, no, you don't have to kill it. It was never alive. And here comes the whole conundrum that is so wonderfully brought to us by so much architecture, design, and art. To make a long story short, at this point, biodesign was in the Museum of Modern Art, and we even acquired a synthetic bacteriophage. It's the usual bacteriophage that everybody uses, but in this case, it was designed using a special software by Autodesk. And of course, we couldn't really have the bacteriophage in the collection of MoMA, but we have a model of it, 3D printed. So all of a sudden, biodesign, like architecture, cannot be owned and collected in a museum, but a representation of biodesign instead can. Very interesting what it brings up in terms of collecting. We also collected several other representations of biodesign. For instance, Revital Cohen and Tur van Balen Kingyo Kingdom project. It's a wonderful project that is represented by this image because the image is so sexy, but in truth, it was almost like an engineering project in which Tur and Revital, together with the doctor in Japan, designed a machine to reproduce all of these beautiful Kingyo fish. They're the beautiful goldfish that are hybridized over centuries and are completely sterile, hybridized by the Japanese. We also tried to really convince our acquisitions committee of the importance of acquiring biodesign. And I very often use this diagram by Neri Oxman that shows the coming together of computational design, additive manufacturing, materials engineering, and synthetic biology. Organic design has existed forever. We have, since the beginning of times, tried to imitate nature, because nature does it best. It builds best, it breaks down best, it conceives best, and paradoxically, computers and digital design have brought us closer to nature than we've ever been. So the idea of having computational design makes synthetic biology and materials engineering and additive manufacturing really come together in an amazing alliance. And this can be seen, for instance, in this beautiful project by Neri Oxman, in which she was able, using fluid dynamics and modeling, to capture the last breath of a dying person to create this amazing death mask that in this case only shows the fluid motion, but in her more recent model and series also can capture the biological materials that are coming out of a person's breath. It's really far-fetched, but it's also real. If we have been trying with death masks since the beginning of times to celebrate the last moments and the memory of a person who dies, what better than this, which is the combination of all these new technologies to respond to very ancient rituals. Hybridization, indeed, is as ancient as times, and this is just a wonderful Chinese artist. I just love Liu Xue, and so I'm always showing these models, but they really stand for the idea of hybrid. Hybrid is old and hybrid is new. It's old because we've done it forever, but now it's accelerated because of computational technology and also because of how times have changed. I always loved, this was a National Geographic special issue with beautiful photographs that showed how the census questionnaire of the United States doesn't make sense anymore. Asking a person if she or he or they or Z is Caucasian, Black, White, Latino, doesn't make any sense anymore. There are so many hybrids right now in the world. To the point that Ai Hasegawa, a great student, ex-student of the Royal College of Art, ex-MIT Media Lab, now happily in Japan, came up with this beautiful project that is only hypothetical, that it's the project that sees a couple of gay women having children by themselves without any input from the other chromosomes. So the idea that we can hybridize to the point of impossibility, and in fact it's called the impossible case, is quite beautiful and quite possible. So as you can see, that our imagination runs wild, but our practice follows. There's so much that is going on and so much that we have to figure out what to make of, because the importance of design resides in making technological and scientific revolutions into life. We're here with wonderful people that not only concoct new materials and think of new possibilities, but also think of how these possibilities can become part of life.
Thank you so much. And I'm sure we'll come back to many of these big questions that you've asked, but I would now like to move on to Jens and ask you maybe first to give us the big picture of what you're doing. So we're moving, I suppose, from the world of MoMA, from museums and galleries and forums for discussion to somebody who is looking at the applications very much through looking at spider silk and how one can apply that in industry. So maybe you can enlighten us about what you're up to.
Sure will. Let me show you at the very beginning a short video on how we actually produce before I go into a couple of slides later on. Maybe we can start with the video.
Cool. Maybe while you're about to do your presentation, just to ask that, I mean, Hautnah, this Biotopia EFS is very much looking at fashion and the world above the skin, but I understand that in your work you're really not just looking at silk on the skin, but also actually looking under the skin. So maybe you can tell us a little bit about that.
Exactly. I'm gonna show you later on that our company is not only doing the biosteel, the fiber business, but also a cosmetic ingredient business and a medtech business, which means that we're coating implants with our silk, and we bring them into the body in order to make implants or other medical products safer. So that's actually very interesting things we're doing. And let me start and then go into that fields with the first. That's actually the last one.
Go backwards. Spoiler alert.
Okay. Okay. So that's that. You know. So that's always when you start from the back. Yeah. So thank you for having me. I'm going to tell you. Paula said nature's best. That's actually what we're doing. We're looking into nature and look what can do nature best. We started now with the spider silk. It's an incredible material, and I would like to take you on a brief journey how we can change with our materials everyday's life. We started actually with that shoe with Adidas, which was the first performance running shoe. We have a fully biodegradable upper. a shoe which you cannot do with any material today. No cotton, no cellulosic fibers. You could do that shoe with. Otherwise, Adidas or other companies would have done it already. So why is it that companies like Adidas would want to partner with us, right? A small biotech company having that great fiber and other things. It is actually one of the reasons is that the industry is facing an unsolved dilemma. On the one hand, consumers, you and I, we want the best performing products, right? We want great looking dresses and great sports shoes. But on the other hand, there is a huge need, growing need for environmental, sustainable solutions, not only from consumers, but also from regulatory authorities. So today, in a world where we have plastic, crude oil-derived, petroleum-derived plastic fibers, those two goals are really opposites. You cannot achieve them. It's impossible, right? And that's why we need new materials. And one of the reasons we are looking into that is McKinsey & Company 2 years ago came out with a study showing that today in the oceans the ratio of fish to microplastic particles is 5:1. And 10 years from now, this is going to be 1:1. So what does that mean? Fish eat microparticles. That's at least plastic microparticles. That's at least what scientists tell us. And we eat fish. So that makes our mission very urgent because around about 40% of that microparticles in the ocean are coming from the abrasion of synthetic clothing in the washing machine. That's the issue we're facing. So what can we do? In the video we've seen that we can produce a material unseen before. It's a natural material without any crude oil involved into that. And we can help companies like Adidas or other large brands to potentially shift their production volumes to a material like ours. So it's companies like us and you know, a couple of other who are here with me on the panel who can really change that. So how are we actually doing it? You saw that in the video a little bit. We're using the process of fermentation. It's a very old process. We know it from the brewing industry, food, insulin, vitamins are being produced like that. We need a carbon source for bacteria to feed them, and then we produce a white powder. And out of that white powder, we go into 3 business divisions I mentioned earlier. One is medtech coating, I'll come to that in a second, cosmetic ingredients, and of course the fibers. And the beauty of that is that this is not only on a lab stage, we're actually selling these already, and they're going to be ready for mass consumption anytime soon. So we are actually combining, and that's why I tend to say we're on the golden age of materials. We combine the scalability of crude oil-derived polymers, infinite scalability, with sustainability and biodegradability of natural materials. So again, as I mentioned earlier, the 2 opposites, we are bridging the opposites with our materials. And we're focusing on 3 markets. I mentioned, and the markets are huge. I mentioned the sports earlier. We do textiles. We have a lot of brands I unfortunately cannot talk to you about in the fashion industry we're working with or who want to work with us. We do personal care, i.e. cosmetic ingredients, where we have very interesting partners. And for example, there the interest is different to the fiber. The fiber I mentioned to you, it's about environment. On the personal care side is you want to avoid animal-derived ingredients or crude oil-derived ingredients as well. And on the medtech side, you want to have safer products. On the fiber, we not only cater to fashion or sports. We have, for example, our fiber, as it is really unique and it can take up a lot of stress. It could help make new materials also in the automotive and aerospace industries. On the cosmetic ingredients, and that's the beauty, that's what I mentioned. You can already buy 40 products from Korea to South America. Products are in the markets using our silk. And we have great properties. For example, the nail polish in the middle is a German product. It is one which can actually protect your nail, but we make the protection breathable, right? We can give new properties to products which people need, which cosmetic companies want to have. That's why there are several hair care, skin care, and also perfumery products already out there. And last but not least, MedTech side, our silk, when you bring it into the body, it has two very interesting features. One is that our coating creates a surface which makes it impossible for bacteria to adhere. So there is going to be no bacteria on that without destroying them. It's very important for not creating inflammatory processes in the body. And the second is that as compared to materials like silicone or polypropylene, we create a natural surface to the body. So the body is not even attacking the implant you're putting into it. It is accepting it from the very beginning. Yeah, thank you very much. I'm looking forward for the discussion with the panel. And yeah, again, thank you for having me here.
Thanks so much, Jens. And I think it's going to be fascinating to explore the different potentials of some of the different materials, from the synthetic spider silk to collagen and others that we'll discuss later. But now I would like to move on to Maurizio. Maurizio, you are somebody who has become obsessed with fungi over a lifetime and is exploring all sorts of incredible opportunities to work with fungi, with mushrooms to create, and mycelium to create new materials. So can you tell us about your journey to the mushroom?
Absolutely, yeah. It's, well, first of all, thanks for having me here. It's a pleasure and an honor to be here. And indeed, it became a positive and yeah, obsession, you could say. Now, just to introduce briefly, in fact, for people that are not maybe familiar with the terms, when we talk about fungi, we often talk about mycelium. And just to make a little bit of clarity about what that is it's actually the vegetative part of fungi. So we are all familiar with the fruiting bodies of fungi, right? The mushrooms. However, there's much more beyond the mushroom. The mushroom is the reproductive stage of a much larger body, which is quite extended and quite complicated to understand. And it's a very intricate network of interlocking cells that goes on all over in the soil, everywhere we step. A little bit of a living web, bringing together the soil and distributing information across different living systems in the soil. So actually, this obsession started somehow from a design fascination which had nothing to do with the intention of creating materials. Actually, it was about a sort of, you could say, anti-design statement. It was about the will of identifying ways as a designer for criticizing our overproducing society, and particularly for addressing the responsibility of both designers and industry. When looking at, again, how much stuff we produce and with which kind of means of production and which kind of materials we deal on an everyday basis. So the beginning of this journey was, in fact, the fact of trying and partner with living systems such as fungi, which are the great recyclers, the great decomposers of the natural world, in order to get rid of all the toxic synthetic materials which surround us in our living landscape on a daily basis, and somehow to sort of try and remediate and come to an ease in terms of the relationship that we humans have to our material culture. However, while going through different projects and examining cycles of decomposition and degradation of different materials, organic and inorganic, I actually started stumbling upon the generation of continuous generation of matter, of biological matter. And that was kind of you could say, a little bit of a coincidental encounter that suggested for maybe taking the project to a different course, which was the one about partnering with living systems for creating new kind of materialities. And so there was this overall idea of actually trying and deal with the idea of the living. How could we try as designers to reflect on the fundamental importance of the cycles that should characterize every existing thing surrounding us, including us. So on one side, there was the intention of making dead materials alive, while on the other, there was the intention of creating new materials which could die because of their very natural origin. And somehow this has been a process that has been dramatically influencing my development as a designer, you could say, because it tremendously affected the nature of the practice that I actually started developing for myself, as it affected, in fact, not only the know-how that I needed to enter this kind of field, therefore, by accessing certain kind of more specific information that became very functional to the work that I needed to do, but also by actually needing to get acquainted with the use of certain tools and methods, which originally clearly do not belong to the design profession. So in some way I show this slide because that's a little bit how the modern atelier of some of the contemporary designers could be seen like. It's a very different operative environment which doesn't compromise for all the traditional tools and operative environments, such as, I imagine, a wood shop or a metal shop or a clay shop. Still, you need all this stuff, but again, the realm within which you operate is very different. Now, to give you a little bit of a ground in a visual way about how seductive fungi could be, again, as I said, fungi are the great decomposers. So what happens? If you actually create the right conditions for fungi to effectively grow on a given substrate, say an organic material, in this case here we are looking at specific fungal strains growing on straw material, well, what they do is actually starting growing and growing in a radial way and expanding their web, their tentacles, you could say. And they do this because they actually eat the cellulose to be found in these fibers. And in order to do so, they degrade the lignin, which is this kind of tough skin that is to be found on all kind of plant matter. And while actually degrading and feeding on these materials, they partly contribute to transform it in a different kind of matter, a chitinous matter, chitin being one of the most interesting and toughest natural polymers. And at the same time, they, within this scope, they contribute to assemble all those individual discrete particles in a cohesive matter. So you could say that actually fungi in this case work as a kind of binding agent, as a natural glue that is bringing together all these discrete particles towards a cohesive mass. Of course, this is very promising. Now this video is much longer, but I'm going to cut it short here, because it offers the opportunity to kind of establish a completely new way of looking at the idea of conceiving the idea of production, very different from the way that we are rooted in, which is based on the exploitation of finite resources. So the idea of actually a production paradigm which is based again on growth, on cultivation, on a as I used to say, on a reactualization of an ancient practice which is agriculture to be transported in the realm of contemporary production of materials and goods of consumption, which of course is a little bit what gave the opportunity to develop initially at the studio level a number of more prototype-based projects which were situated in the art and design realm. So there were multiple explorations which were touching upon different fields, multiple typologies of applications from, you know, tableware, shoes we are looking at here, some furniture examples, some interior examples, and so on. But somehow this became very limiting and very frustrating as well, because, you know, the scopes of this project are much wider, and you think, okay, this is a very promising kind of technology and potential set of applications, and they should touch upon the life of the many. So we embarked on a journey which has been a major challenge we are still in the middle of, and we started and incorporated a company back in 2015 called Mogu, which is based in north of Italy in the province of Varese. And with Mogu, we are basically scaling up and standardizing a number of mycelium-based materials and products, actually being almost ready for our first collections to be released in the market. Besides all these composite materials, which look more at the realm of the interior and interior comfort for the time being, we have been exploring, and we are still actually in R&D phase, but we have very, very suitable results so far, the possibility of developing other typologies of materials which touch upon applications, for instance, for the fashion industry.
We start with cell engineering. So we have a team who are taking yeast cells, but instead of feeding yeast sugar to make alcohol and therefore beer, we take yeast cells, we feed them sugar, and they're producing the collagen protein. So collagen is the majority of the material that makes up the animal's skin. except that you don't need to kill the animal to produce that protein anymore. So we're using, similarly to Jens producing spider silk in bacteria, we're producing collagen proteins in yeast. So we are literally designing and editing the DNA of the cell to produce the collagen, and then we use a fermentation process to multiply those cells into billions and billions of cells. And then we purify the collagen protein, and we assemble it into material structures. So this is one potential output of that. So if we think very traditionally, leather comes in a sheet form, but it's very much subject to the shape of the animal. So when you take the hide off an animal, you know, it has this very irregular outline. And if you're trying to make a handbag or a pair of shoes or a jacket, there's an awful lot of waste. So the waste ratio on a leather skin can be anything between sort of 50 to 80%, depending on what you're producing, because you're trying to make the material the same all the way over. When you're producing material like this, you actually only produce the material in the shape that you need it, with really minimal waste. So we can form it as a sheet, like you see here. We can create any color. The texture that you see here is actually not embossed or stamped into the surface. These textures are actually emerging as we're assembling the material. And that's one place to start. So that's really thinking quite traditionally about trying to copy and mimic what an animal skin looks like. But I think it gets much more interesting when you really open up the possibility of design working with a protein in this form. So we had the realization that in the beginning, once we have our collagen, it's in a liquid form. And another way of thinking about that is actually what we have is liquid leather. And if you think about leather in a liquid form and the design possibilities of that, instead of thinking about just making two-dimensional flat sheets, suddenly you're unbound by what nature has given you, and you completely open up the realm of design and engineering. So we can take that liquid leather, we can add in the pigments, the dyes, and the tanning chemicals to preserve the protein, but then we can start having fun with it. So this image is actually, one of the ones downstairs on display is showing two colors of leather coming together. So having a vat of black liquid leather and a vat of white leather, and literally marbling them like you would if you were making a cake. We could similarly take that material and form it into a solid, and if you sliced it right the way through the material, you would see that mix of color. So that's completely impossible to do with an animal skin. And for me, that starts to really explore what is possible when we are freed from the animal. This is an example of us rethinking the grain. So yes, we can mimic that beautiful natural skin-like texture, but we can also do things like this, which are much more geometrical, much more three-dimensional, where we can introduce all kinds of new textures, new aesthetics into the surface of the material. And these are all actually composites. So we're putting that grown collagen tanned material into other textiles. They're not glued on the top. We're actually embedding it, locking it into the textile itself. And you know, this is what happens when you bring designers and scientists together in the lab. If you have a solution of liquid leather, then why not start painting with it? So this was exploring the idea of creating a leather lace material. So literally drizzling and laying over the material. So you start building up thickness, but just where you want it. So if you translated that, for example, into a shoe, you might put the liquid leather over the toe or over the heel just as a reinforcement, but it allows you to really control, you know, things like thickness and weight and just applying materials where you want them. And then actually we had an exhibit in New York last year where we showed a lot of these provocations. So these are not actually yet commercially ready samples. These are things that are coming out of our design lab. And this was actually the most popular sample that was sort of voted for by the public. And this is as far removed from leather as is possible to get. So this is actually nanofibers of bioengineered collagen that have been dyed and tanned and then sprayed onto a silk substrate. So this is impossibly light and drapeable and unlike any leather material or in fact silk material that you've ever seen. But I think it sort of hints at, we mentioned about mushroom materials and silk coming together, but collagen and silk coming together. So the interplay of how we might bring those materials together, I think, is really quite exciting. And I had to include this one. So those previous samples were very much the product of inspiration that came out of this project. So this T-shirt was actually commissioned by Paula for her exhibition at MoMA last year, Items is Fashion Modern. And this T-shirt really was for us about pushing the way that people think about leather. So we didn't want to produce something for MoMA that was expected of us as a company reimagining leather. So we could have created a handbag or a shoe or a jacket or one of those more traditional leather products. But we said, no, in a world where we can now biofabricate proteins to make leather in a lab, let's completely rethink about how we use that material. So we took the white T-shirt, this very timeless garment, and we took it apart. We replaced a couple of sections with new material, so you can see a couple of like sport mesh materials. And then instead of stitching it back together, we used the liquid leather to literally form the seams in a stitchless way. So the liquid leather becomes not just a material, but also a manufacturing technique. So we're using the liquid leather instead of a sewing machine. And the design of that pattern actually came from studying the grain on a calf, so calf skin, but then exploding the scale to a very big, just blowing it up. So it becomes quite abstracted. So we're sort of interested in playing with ideas around how nature does it, but then really freeing ourselves as designers and rethinking how we might work with those materials. So I just want to end. I think we have a short video. If we could maybe turn the music up as loud as possible and run the video. Thank you.
Great, thank you, Suzanne. And some of you may have seen that there are the samples of Suzanne's, of the Zora material downstairs, which you can see but you cannot touch because they are very, very precious. Just before we move on to Fiorenzo, just one thing I was wondering was, people speak a lot about the tanning industry and having a lot of negative environmental consequences. Clearly it's wonderful to have these new approaches to leather-like materials, but how does one get around the issues with the tanning industry? Are there similarly revolutionary things happening in there? Or?
Yeah, I mean, I think there are similar opportunities for being much more efficient in the way that you bring the chemistry together. So we do still need to preserve the protein. So that's the real function of tanning. First and foremost is to stop that biological material from putrescing.
Yes.
But because you're working with the very pure protein already in a liquid form, you can use much less intensive chemistry to actually work with it. And you can reduce the number of steps, so you can start to bring together dyeing and tanning and finishing in a reduced number of steps. So environmentally, there's going to be a big change in the way that we actually bring those steps together.
Thank you. So our next speaker is Fiorenzo Amonetto. Fiorenzo is the founder and I suppose in charge of the Silk Lab at Tufts University in Boston. He's going to be talking to us about silk. Silk, one might think, why do you even need a silk lab? Silk is this ancient material. What's so new and exciting about silk? And some of you may already have these little cocoons of the silkworms, which are downstairs, which are quite wonderful, actually. And they fit exactly on your fingers, so they can be hard to get off. But Fiorenzo, why is silk a material of the future?
Well, maybe we'll get to it a little bit. I think there is a big message in materials, and it was a perfect segue from the end of the movie that Suzanne was showing. What if materials were the revolution? And I think silk for us is an excuse to think about materials differently and to think about a platform that really brings together technology and the natural sciences. I am a technologist by training, and so I think of these things in the eyes of electronics and photonics, and so the camera in your phone and the processor in your phone, so to speak. Thank you for having me. If this is what Biotopia is going to be, it's going to be phenomenal. It's really a delight to be here. So the one thing that we do is that we use natural sources. So unlike growing, the synthetic process to generate the fiber, we really take inspiration from the factory. Instead of fermenters, we have the worm, and the worm is a very, very sophisticated machine that threads that spins this 1 kilometer of uninterrupted fiber, and you've seen them downstairs. This worm is operating a little bit faster than the ones that you've seen downstairs, thanks to the power of the fast forward button. But the one thing that the technologist sees is that you see, to me, this was laying of an optical fiber. The material is very transparent, and this is an additive. This is a 3D printer. The process that the worm is exercising here is an additive manufacturing process. It's the quintessential additive manufacturing process. And what we do is that we take a lot of the fibers that are destined to the textile world, that we break them down. And so we go back to the liquid solution of water and fibroin protein that the worm stores in its gut in order to spin this technical fiber. And so they are, why would you do that is really not too much. You can generate a lot of forms, but I think it's important to do these things because of the attributes of these materials, and this applies to a lot of the natural materials that you've seen downstairs, and I think a lot of the natural materials that surround us. Nature is a problem solver for sure, and nature is a very, very good engineer, but nature also uses construction blocks, and these are the construction blocks that we care about, and the issues here is that the material is sustainable and can be sustainably sourced, but the important functions and avenues of interpretation that make these types of materials exciting are the fact that they are processed in water and that the processing occurs at room temperature, that you can make the proteins assemble when you hack the process. You can make them assemble into materials that have controlled degradation states. They can last forever or they can dissolve instantaneously when you drop them in a glass of water. You can eat them. You can implant them, as we've heard before, And an important key of interpretation is that when you mix things in this neutral pH, room temperature, water-based environment, when you mix biologicals inside this, the forms of the materials that you get maintain preserve that biological function. And so you do get, if you will, materials that are biologically interactive. This is what it means when you have functional materials and when you have unexpected behaviors, which then affect a lot of fields. The fields of technology, the fields of design, the field of fashion. As you've seen downstairs, one of the functional materials was an ink made of silk that contained an active chemistry that you can spray and watch change color. And this is an example, a simple example of interactivity. But because you have this merge of form and function, then you can start thinking of very unusual outcomes such as these. And so this is the challenge. As we talk about design, we talk about fashion, we talk about a lot of things, but there are also bigger impacts that materials can have, and this is our passion in the lab. What you see in the pictures above is what the cold chain looks like for vaccines. It is a horse, it is a donkey, and it is a cooler to bring vaccines in remote areas of the world. So the fact that you can maintain biological activity and that you can give form to these materials means that you can reshape the protein into that microneedle array that is both a delivery mechanism and a stabilizer, so that a polio vaccine does not need to go in the fridge anymore, and you can just put it on your tongue and melt it, or a measles vaccine can be just applied on the skin. And so these are the unusual ways where the worlds merge, and can go into these scenarios where you start having circular effects, where the materials start helping situations of depletion, such as carbon footprint. What you can do with liquid silk is you can dip a fruit and have it form a thin coat that is an edible membrane that controls the respiration of the fruit, so that you can preserve a strawberry at room temperature for 10 days, or a banana for 10 days without it having to brown. So these are unusual interfaces and unusual functional aspects where the form and the function are merging, and that really address a serious problem, a problem of 30% of our food is thrown away. There's a strong contribution to the carbon footprint and so forth. So these are the types of things that we look at. And if you see the bottom two pictures instead enter into different types of interfaces and different types of functions, where the material properties and the material qualities then become a little bit more dystopic, and where you start matching biologies and interfaces and start thinking, instead of the Internet of Things, the Internet of Humans. And so what you see in this slide is you see edible sensors that are made of gold leaf that is basically reshaped like 10,000 antennas that are sitting on the surface of an apple, or a little silk sandwich with antennas that sits on your tooth and continuously samples the saliva and reports on what the state of biological markers are in your mouth. Or you get to these things where you start doing implantable tattoos, we start doing light tattoos with implantable light sources versus electronics that melt and that you can consume. And eventually think about composting a phone or a device. And then you can 3D print organs too, and that's another long story. So basically what we are interested in is in trying to modify the relationship between form and function. And we can do a lot of forms that ranges really from making polystyrene-like cups, to making fuel cells, to printing objects, to making inks that change color and that affect the way that we think about the material constituents that then inform the way that we design objects, we design interfaces, and we design outcomes. So.
Wonderful, thanks. I'm not sure if I want to sign up for the Internet of Teeth just yet.
The Twitter survey also was an overwhelming no.
Brilliant. For me, it's interesting that when one sees these beautiful videos and so on, it all seems incredibly easy, like creating these amazing new biological materials. Is it really that easy? Is it effortless, or if not, what are the challenges around biofabrication?
Well, maybe I
Yeah, no.
Suzanne, start. Please, you start.
No, I was just going to give you some numbers. I mean, I think it's, so I've worked with Modern Meadow for 5 years. We are currently a team of 75 people. There's probably around 60 scientists involved in that. We've raised about $55 million, and that's before we bring a product to market. So I think the first thing to really understand is just the timeline for this kind of work is not measured in months. It's very much about bringing together super interdisciplinary teams, not just between design and science, but even within science itself. So chemists, biologists, engineers, material science, and so on. And that is definitely an adjustment for designers. The first thing I think I learned in this field is patience, because the R&D that happens in this field doesn't take place on the same timeline as the sort of product development timelines that we're more used to with traditional materials or existing materials.
Anyone else like to answer on that one?
So maybe I can add. I mean, our company was actually a spin-off of the Technische Universität München here. So it's very Munich-based.
But also Bayreuth is involved too, no?
Bayreuth is involved. So the founder is now at the University of Bayreuth. He's chairing the biomaterials there, Thomas Scheibe. And actually it took us now, the company is alive for 10 years, and there was research before at the university. So what you see in the large fermenters, right? I mean, if you have a fermenter of the size of, of 2 or 3 stories of this room where we actually produce today, it took many, many years and of course a lot of money as well to invest. But when you're there, right, you can really change things, right, and come up with new materials, and that's great. So it's worth the effort. That's what I want to say. Put in the time and the money.
I would like also to add that Suzanne started a conference called Biofabricate that this year was in its 5th year. And the first year, everybody was like dreaming, saying, I want to do this. And this year, they're companies and they're bringing products to market. So, and they had started even before. So Modern Meadow, I think I've known Andras for 8 years, and I've seen him readjust the aim a few times, always with the same material but with different applications. So it's taking a long time, but I have to say it's all coming together now into the world, and it's really exciting.
It seems that there's a lot of investment in this area going on at the moment, and you mentioned, Suzanne, the investment in Modern Meadow, but there are a whole slew of new companies popping up everywhere. Why now? Like, why is suddenly there this interest in sustainable materials?
Well, I guess I made the point. I mean, when you look at the oceans, for example, I mean, if we have a ratio of 1-to-1 from microparticles, no one knows what happens, right? I mean, this is unbelievable, and this is only the oceans. I mean, we burn the stuff, we burn the shoes. I mean, Nike produces 500 million pairs of shoes, and those shoes, each of those pair of shoes, stays with us for 400-500 years if we don't burn them. No one really knows at the dump where they are, what happens to the soil and to the water. So I think that is something. But
Adidas shoes, how many years would they stay with you than the spider silk shoes?
I believe round about the same as the Nike ones. So no, I mean it's. I mean, our shoes certainly. This is the beauty. If you take our shoe, you put it into the waste, right? And there is kind of bacteria and enzymes with it, and it biodegrades, right? Because it's a natural material. So and that's great, because one gentleman at Adidas said cradle to cradle, right? You start not with crude oil, but you start with the fermentation. And in the final end, you go back to the soil, right? And this is, I think, the concept of the future, definitely.
But the lower part, you said, is not like that. Maurizio should do the lower part, right?
Could be,
Yeah.
yeah.
There you go.
I think, though, I mean, that's not the only reason. There might be many more reasons besides this kind of environmental responsibility that individuals, designers, and companies take. It's not just this kind of purity of thought. Of course, there is a lot of corporate social responsibility involved, which sometimes, of course, promotes certain initiatives rather than others. Of course, there is the necessity of identifying different forms of energy and different generators of materials, as in fact we have been depleting our natural resources till a point that is maybe a no-return point. And certainly the accelerated convergence of biology as a form of functionalized technology is kind of progressing really quickly, and therefore it's offering many more people the possibility of envision how to being empowered by certain tools and certain notions that before were maybe alien to the many. That doesn't mean that, in fact, to come back to your previous question, it is an easy game, no matter which is the field. As if I think about the different presentations and the different subjects that we've been touching upon, some might sound a little bit more fiddly and a little bit more complicated, and other more straightforward. However, I think none of them is easy to achieve. And I say this because I think it's very important to effectively communicate to younger generations, but not only, the fact that all of such practices require a lot of commitment, require a responsibility to actually keeping trying and keeping failing and taking failure as a very positive opportunity for actually exploring how to progress better. There's no short-term results whatsoever. And I think we all possibly have experienced the same kind of thing in different realms. Yeah.
Thank you. I would like to shortly give the word to the audience, and I'm sure I hope you have lots of questions. This is really a unique chance with some amazing people here on the stage. But before I do that, so please think of your questions, but before I do that, just to follow on your last point about, we have quite a few young people in the room here. We also have some amazing young people who have created a lot of what's in the building today in our Biotopia Fest. And I for one was blown away by the projects downstairs done by the Hochschule, by Ralph Ammer students, and many of the other projects. But what would be your advice that you would give, suggestions, or what do you think is the best way for someone to get involved in this area if they're excited by what they've heard about today? How can they get the start?
I was just going to add to what Maurizio was saying, which is that they've all taken that first step, which is the really important sort of getting immersed into the field. But if you're really excited about it, then committing to that further research and really seeking out maybe the environments like your lab or companies like ours that are already embracing designers and scientists coming together into the lab. But following that passion, if there's a real passion for the subject, pushing it to the next level. And I know that this is something that you've talked about a lot, and I think we as designers have experienced that transition into a commitment that is really a life commitment to a material and to a material practice.
And that life commitment actually also embeds the necessity of, again, getting acquainted with so many, very many different fields of expertise, where you don't want to become necessarily the expert in each of those, but you need to be relatively competent in each of those. And as a designer, for instance, that maybe starts and promotes the emergence of a certain initiative, you are responsible for the creation of such, call it, transdisciplinary team, and for the fact of making it effectively work, letting such competencies be capable of talking to each other, of working with each other. And I think that is sometimes one of the biggest difficulties also, the effect of learning to speak a similar kind of language, or a language that can be mutually understood.
I think that's if I may add, I mean, that's an issue, right? I mean, again, go back to the 500 million pairs of shoes. There is no way to change this overnight, because obviously the shoes coming out of those materials we're talking about here are a little bit more expensive. They don't cost double the price. But we as humans, we're very, price conscious. So we would always strive to buy the cheaper one, right? And so regulation is one thing. The other thing is, and this is what we're working on, is really produce as much as we can, scale the price down in order to go somewhere close to the prices which are in the market for other materials. And I think that's without any regulation, that's what you have to do, because regulation is one thing. Sure, it may help on the plastic side, but this cannot happen overnight, not by regulation, because we need the goods, right? We need to have them. Someone needs to produce them, unfortunately.
Great. Are there any other burning questions from the hall? Yeah. Yes, one here and then one here. Yeah.
Yeah, I just want to hook on the statement just mentioned. I find it very interesting when we talk about value, about lowering the price. Of course, in like industrial context or in market context, we need to produce, how do you say it, bigger masses, bigger series to put the price down. But in nature, is that a strategy that also works in nature? Or because in nature we have a lot of, how do you say, diversity. There are also a lot of things living parallel to each other. Is there maybe also a different way to boost, let's say, this bioeconomy without scaling up? That's just a question to you. Is this growth of scale really necessary, or could it also be more creating diversity?
Well, in my opinion, it's not just about a matter of scale. It's about a matter of optimizing and attentively selecting the resources that one uses. And well, particularly, I'm a bit biased in what I'm going to answer because, of course, it's at the basis of the very processes that concern the work I'm carrying out. But it's about the cycling of nutrients, and it's about the capacity of introducing inputs as values, which are in fact low-value materials deriving from other processes. What these days is called kind of circular economy, even if the definition of circular economy is a little limited. So actually the fact of identifying compounds, and we live in a wealth of materials surrounding us that we actually think are completely meaningless. The fact of being able to take them up and revalorizing them through different natural technologies by employing living systems, which are the skilled ones for transforming such compounds in something of much higher value, is what we need to look at. It's not just about the scale. Of course, the scale can contribute to cut down certain costs.
Can I just add one thought to this? And I think that also nature rarely optimizes for scale production. Nature optimizes for function. So this goes back to what I was alluding to before. So nature optimizes the way that it builds. It builds dynamic materials, and this is a functional aspect that for the right reason or wrong reason, is not present ubiquitously in manufacturing today.
We have a question here. Yeah.
Thank you. My name is Amparo Lehman. I live in San Francisco, and thank you so much for the panel. And you're talking about materials, and I'm wondering about biofuels. If this research that you're doing and breakthrough on materials can also impact or use biofuels in order to make everything sustainable, not only the final product, but also the production. In most of the videos, very nice machines and everything that is still using dual fuels, so I wonder.
Who would like to comment on biofuels?
Biofuels are great. Well, I mean, there is. I think that there's substantial effort. I mean, right now, it's unclear. It's unclear where the production, where the life cycle. I mean, everything. Enzymatic fuel cells, for example. Enzymatic fuel cells are cheap. They could be a great solution for a lot of energy shortcomings, energy applications. You could ferment the enzymes and the enzyme pairs that would make batteries. The problem is that you do need to feed them, and this is one of the issues. And so it's a symbiotic place where it's a symbiotic situation where it's not only the generation of the organism like people do. I mean, synthetic genomics comes to mind as a company that does these types of things. But then you have to insert it in a system where this grows and this. So it's a sort of like a fermenter battery. I think it'll come. I don't know when, but I think it'll come.
Thank you. So we're going to have to leave the room in a few minutes, but please, yes, one last question here, and then...
Just a short one. How do you exactly dissolve silk in water at room temperature? How does this work?
amazingly well. So you basically control the way that the proteins come together, and you control the kind of like the ratio of bonds that they make with each other or with themselves. And so depending on how the materials assemble, there are more spaces for water to get into the material and break the material apart. No. You can do it in water, and then the more you play with these bonds, and the more you make solid materials, then you change the degradation rates, and the degradation rates are very slow, and so you use enzymes instead of water, but you still break down. You go through these little kind of like molecular doors that are left open for bonds to be cleaved and protein to be broken down.
Thanks. So in a couple of minutes, we're going to have to end, and we're going to have to make way for the setup for this amazing fashion show, which will happen at 6:30 with the Deutsche Meisterschule für Mode. And it's Science Catwalk also with Susanna Renner, the director of the Botanical Institute here next door. And you also now will have just a few minutes to have a last look also at the exhibition downstairs if not everybody has seen it yet. But before we end, I just wanted to ask our panel once more, maybe just to give very succinctly what you see to be the key frontier for this area of new biological materials from your perspective. So maybe just very quickly, we could just go around once. Maybe, do you want to start and we'll end up here?
To me, it's the disruption of form and function. It's materials that will do what you don't expect them to.
Suzanne?
No, I agree. I think it's about changing the nature of the products themselves. So, our materials, we're thinking about thinner, lighter, stronger. What can it do that the existing materials can't do?
Exactly, and in addition to that, it's just about the way in which we work with those materials, and therefore how the production processes are modified accordingly. So yeah, I think that's one of the biggest impact that is going to touch upon our lives and industry at large. And by the way, just to add one little thing, I think this is in fact what is going to let us come a little closer as part of what is supposed to be a very inclusive system, which sees the human reconnecting to the fundamental linkage that already exists with all natural systems surrounding humans, stopping defining the marked line of separation between human culture and nature, and on the other side, bringing us back together.
Yeah, maybe I may add, I think one should really look more into nature. We have looked into shark skin, we have looked into winglets, we looked into spider silk. Spiders are on the earth for 300 million years, way longer than we are. So look at nature, nature is the best creator, right? If we can then use that ideas from nature and can biotechnologically reproduce them, and have them in different forms, like in a liquid, as we can, and then from a liquid you can produce not only fibers like a spider can, but also coatings and other products with very superior properties. That's great. So I think really, turn back, look into nature, what it has given to us, and what can we learn, and how can we use it for us to make the world a little better.
Paula.
To me, the final frontier is seen from the other side, from the people and that buy these objects. And the final frontier is adoption, embracing these objects. They finding them so irresistible that they become objects of desire. The way there are sneakerheads that possess 150 pairs of non-biodegradable sneakers, all of a sudden I would like to see this biodegradable sneakerheads that possess 3 super precious and absolutely biodegradable pairs. So I would like to see all of these good things become objects of desire.
Thank you so much. And I hope you're enjoying Hautnah, our Biotopia Fest. I would like to invite you to join me in thanking our wonderful panel of material revolutionaries.
Thank you.
Thank you.
Thank you, Michael.